Welcome to September's Leetcode challenge. Today's problem is repeated substring pattern. Given a non-empty string, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. You may assume the given string consists of lowercase English letters only, and its length will not exceed 10,000. If we're given a string like ABAB, we can clearly see that it can be constructed by substrings of ABAB. ABA, however, cannot. ABC, ABC, ABC can, because we can see ABC is just constructed 4 times to create this string. So how could we do this? Well, let's start with not overcomplicating it and go through a straightforward brute force approach. If we were a human being trying to solve this, we might start with just checking the first substring possible with a position of 0, length of 1, let's say, and just check to see if all other positions moving forward equal it. And we can clearly see here it's not going to be. The next one immediately is not A, so we can break out of that. Then we can check the next position of 2, check to see if the next one's AB as well. It's not, so we break that loop. Now what about ABC? Well, ABC is ABC for the next one, same with the next one, same with the next one. And that would return true. And really, we would only need to go up to the midway point, because for these to be able to be constructed together, length matters. So all we would need to check is up to the length of the halfway point. All right, so let's start with that. Let's write a function. Well, let's first initialize the length of our string, and we'll write a function called pattern. And what I'm going to do is pass in like the position, or it's really more like the length of our pattern. So I'll just call that n, and we will do a for loop and say for let's say I in the range of start from the beginning, because we'll always start at the beginning to check this, and we will move to the length of the string minus the length of this substring pattern. And we want to jump also in lengths of the end of the substring pattern as well. So what we'll do is just check, hey, is this substring from I to I plus n, does it not equal I to the I plus n to what? I plus 2 times n. Right? I realize that's a little ugly, but it gets the job done. If this is not the case, we just immediately return false. It's only if we can get through the whole loop we can return a true here. So this will be our function that's going to detect whether this pattern exists for the whole string. Now all we do is just say, all right, for j, let's say, in range of 0 to the length, we can, like I said, all we need to do is go to the midway point. And because of the way I wrote this, I actually need to pass a 1, and we need to pass a 1 here, add 1 here to make sure that we get the midway point as well. And just check, hey, if pattern of j, if we ever return a true there, we can return true. Otherwise, if we check all these and none of these work, then go ahead and return a false. So this would be the straightforward method. ABA seems to work. What about AB, or ABAB works? What about ABA? That doesn't work. Let's go ahead and submit that. And accepted. So this is an exponential solution. It's actually n times the square root of n. So not quite n log n, but pretty close. So it's not bad. But can we do better? And of course, there always is a way to do better. And this solution is really tricky to explain. I would have never thought of this, but if we had, if we just added the substrings together, or the strings completely together, and got rid of the first character and the last character, and then just check to see, does our string exist in our, I guess, data structure that we just created, that actually indicates to us whether this pattern exists or not. So this actually would work in itself. It looks so easy, but why does this work? That's what's hard to explain, because let's just say I print this ds here and have the word hello. It's got something to do with the way this string gets rotated. if we could find that pattern, add these numbers together, this pattern should exist in this rotated pattern without the first character and the last character. The first character is always going to be part of this substring pattern, and the last character is always going to be the last character for the substring pattern, right? So there's a mathematical reason for why this is the case. Here you can clearly see it's not going to work, but if we did something like ABAB, and I ran that, this would show this ABAB exists inside here, meaning that this pattern actually does exist. So I don't know if I'm explaining that very well. It's pretty complicated, but it does work. So this is an O of n solution. Now really, I don't particularly think this would be very intuitive. So I suppose it's one of those things you know or you don't. The straightforward method, brute force method, actually seems to work fine. But if you want to optimize, then this might be something you want to memorize. You could look into it. So thanks. That's it. So thanks for watching my channel. And remember, do not trust me, I know nothing.